Hi everyone, welcome back to Mind Over Math. This is part one of a three-part series on quadratic equations and their vertex form, intercept forms, as well as graphs and practice problems. This is a three-part series. Hi everybody, thanks for stopping in. Let me remind you to subscribe, like the video, and comment down below with ideas that you have for future videos or questions you might have. Thank you. This presentation is on quadratic equations, which are parabolas, and these have three different forms. And you can learn something from each form. Each has a strength, each has a weakness. The quadratic equation is simply ax squared plus bx plus c. This is the one we use to do factoring with. We may also use the quadratic formula if that does not factor. The next important thing about this is the y-intercept. The y-intercept is that constant c right there. The one without the x on it tells you the y-intercept. That's a very simple thing to pick up that a lot of people miss. You'll notice up here when I talk about x-intercepts, I let y equals 0. These are in instructions usually use solve, find the zeros, or even find the roots. These are all about the same statement with slight shades of differences. You'll notice on the y-intercept that we let x equal 0, not y. That's for the x-intercepts. We let x equal 0. The axis of symmetry is a formula. You'll notice the a and the b come from the ax squared plus bx plus c. So this means negative b over 2a. And the last thing we look at in this form is the vertex. Now, if in any of these the a is a negative, the graph is a maximum at the vertex, or if a is a positive, that means it opens up. The vertex is the minimum. So coming back to the intercept form, we have to take the axis of symmetry, which we get from negative b over 2a, we plug and chug into the original function. Each function changes with each problem to determine the y output for the vertex. With vertex form, this is sometimes called transformation form. We'll notice our three letters again are A, now H, and K. We solve these by using square roots to get our x-intercepts. Our y-intercept, we do the same thing in this entire column. We let x equal 0. Get this, our axis of symmetry is actually the H, whereas the vertex is HK. This form gives us a lot of information about the graph and is very useful. The last form is called intercept form. That's the bottom one here, and you'll notice we have an R and a T, and we'll let those stand for root. So these are the perfect case. This is an already factored problem, and all you have to do to find the x-intercepts is set each of them equal to 0. That is, we're letting y equal 0 to stand for the x-axis. So these are the simplest. They're already factored. All I have to do is set them equal to 0, and I get my x-intercepts. Hey, the y-intercept is exactly the same as all the rest. We have to let x equal 0. And then this is a little different. If you know the two x-intercepts, you just add them together, r plus t, and divide by 2. This is the midpoint of the two x-intercepts. That makes sense. The axis of symmetry cuts right down through the middle of the shape. It also cuts through the middle of the two x-intercepts. And last of all, once we know what x equals here from our axis of symmetry, we substitute it back into the problem. We plug and chug again, just like we did up above here, once we find the axis of symmetry. An example of that would be y equals x squared minus 4x minus 5. You'll notice as factors, so we let y equal 0 because y equals 0 is the equation of the x-axis. It factors into x minus 5, x plus 1, and we apply the zero product theorem to this and set each equal to 0, and x is 5 and x is negative 1. So I'm going to mark those over here on my graph. Now you'll notice we want to find the y-intercept, which is easy as can be because it's already given to us. The y-intercept is a. So a in this case is negative 5. So 0, negative 5 over here on the graph is the y-intercept. So the x-intercepts are negative 1, 0, and 5, 0. So we've got those x and y intercepts, which really helps us on our graph. The next thing we want to do is find the axis of symmetry, and we use the formula mentioned before, which is x equals negative b over 2a. b in this case is negative 4, so I have minus negative 4 over 2 times 1. So this gives me 4 over 2, which is 2. So that tells me the axis of symmetry goes at the graph at x equals 2. Next thing I want to find here, so we did find the axis of symmetry. So the next thing we want to find, and the last and final thing we want to find, is the vertex. So once again, we take this x equals 2 and we plug and chug. We plug it into the original equation, f at 2. That's what y means here. Y is substituted by f at 2. And we plug it into the original equation, 2 to the second minus 4 times 2 minus 5, and we get negative 9. So that means my vertex is 2, negative 9. So that puts it right there. So now I can make a very good graph from this. Remember, this point right here gets duplicated over onto the opposite side because this is a parabola and it's an axis of symmetry. So this is kind of what my graph would look like, a parabola. Here the entire problem is all written out neatly. So again, 2, negative 9 is the vertex, 0, negative 5 is the y-intercept, negative 1, 0 is the x-intercept, 5, 0 is the x-intercept. Duplicate this back over the axis of symmetry again. There's my axis of symmetry. And so my graph is an open upward parabola. Little reminder, what happens if my quadratic doesn't factor? Well, that means I have to use the quadratic formula. And I want to remind you that the quadratic formula actually contains, look at this, the axis of symmetry formula. This is a 2-for-1. If you know the quadratic formula, you automatically know the axis of symmetry formula. So let's see this work. First I plug in my b, which is a negative 4, plus or minus the square root of b, which is negative 4 squared, minus 4 times a times c, all over 2. So this gives me 4 plus or minus the square root of 16 plus 12 is 28 over 2. 28 reduces to 2 times radical 7 over 2. And so this would be my x-intercepts. Again, I want to remind you, though, that the lead term here turns out to be the axis of symmetry. So that's always included. That should have been an x right there. So x equals 2 is the axis of symmetry. It is actually incorporated into the quadratic formula. In the upper right hand corner, make sure you subscribe. In the upper left hand corner, make sure you check out other videos. Likes are below and make comments on topics you need.